Hello once again, denizens of the aluminum kingdom. I have a short video here in where we're going to calculate bend allowance using the formula, the formulaic. I draw the unhappy face because so many people don't like to do the math, and a lot of times I found it's because we're plugging things into a formula and we're not really sure why they're going into a formula. So we're going to cover this one together. We're going to calculate the bend allowance. Well, for us to do so, there needs to be a few givens. One, in this case, metal thickness. That would come from our drawing specifications, or we measure the metal on the part that's damaged that we're going to fix. The other is the radius. Same thing. It's either given to us on a drawing, or we will calculate, measure, determine based on the old damaged part. And then finally, bend angle, same thing. So these are all things that are given to us or we find out through inspection and measurement. Once we have this information, metal thickness, radius, and degree of bend, we can solve for bend allowance if we don't have the handy dandy chart. Now, I'm a big fan of this, and we all know why, and I know you are too, but I'm going to do this at least once with you. So here's our formula. 2 pi times the radius plus 1/2 metal thickness divided by 4. Now, I will say that this is our formula to find a 90-degree bend. And you go, well, I get it, the radius, that's the amount of curvature. 1/2 metal thickness, well, if you think about that, if we've got metal thickness and we're wanting to calculate curvature, if we base it on 1/2, that puts the line right down the middle rather than being on the inside or outside. So that kind of makes sense. Radius, how much curvature, 1/2 metal thickness, that allows us to calculate not being on the inside or outside, but right in the middle. Finally, divided by 4, what's going on there? Once again, remember back, all of our bends are based on that shape, right? Some form of a circle. That represents the radius of the bend. And in this case, if we divide by 4, what we would be dividing is 360 degrees divided by 4. And guess what that equals, folks? 90 degrees. Now, if this wasn't a 90-degree bend, try to guess what denominator would be down here. By golly, there you have it. That way, I could calculate the bend allowance per degree, and if it wasn't a 90-degree, I could just multiply the 1-degree factor times the number of degrees that I desire in the bend. So moving forward, this is what we're dealing with. Circle, radius, metal thickness, division of a circle. Well, in this case, 2 pi, we'll just use 6.18 times the radius. Well, the radius is 0.1875 plus half the metal thickness. Well, the metal thickness is 40 thousandths. So what I'm going to do is drop my addition sign, and half of 40 thousandths, you betcha, 20 thousandths. And I'm going to divide that by 4. So if we drop down and start cleaning this thing up, let's see, 0.1875, you do the math, stop as you need to, plus 0.020. Well, that equals 0.2075. We're still going to have to divide all that by 4. So now let's come down and clean this up a little bit. We would take 6.18 at this point times, let me clear up this calculator, 6.18 times 0.2075. Well, by golly, we've got a whole new thing going on now. 1.28235 divided by 4, and that equals 0.32, and I'm going to round this one at the third digit. Since it's 0.3205875, we're going to call that 0.321 inches. Now, that's the metal that I would need to allow to make the radius in my flat layout. That would be our BA, or bend allowance, and that's how far between my bend tangent lines, 0.321. That would allow enough metal to make the curvature of the bend once I go to my sheet metal brake. Now, in order to check our work, what we can do is simply go back to the chart here, and I'll provide everybody with a chart. And let's look at our factors. I'm dealing with 40 thousandths metal. I'm dealing with a 90-degree bend and a 3/16 radius. So if I go across the 40, drop my 3/16 column down, look at there, we are landing at 0.323. We just did the math. We ended up with 0.321. You go, well, there's some difference there. Yep, there's 0.02 of an inch of difference, and it has to do with decimal and rounding and calculator use. On the formula charts, like I had just shown you, they have done a lot of long decimal stuff. I rounded some things off, so we're 0.02 apart. We're about half the width of a sheet of paper there. What does this tell me? It's such a small factor from using the chart and calculating and rounding that either way, I will be very, very good when it comes time to make that bend. So remember, this is the formula, and the formula could be used without a chart. By the way, this is the coolest little book ever. It has all this handy-dandy reference stuff in it, and because of that, I always try to keep one handy in case, you know, the batteries die and the calculator and the internet fails and the power system fails, and it's not going to happen. These days, it's so much easier to use a chart that in my class, you're welcome to use the chart, but I did want you to see this at least one time in case it shows up in the future. And once you realize this formula is not so mean and heavy, that it's asking for some things that make sense, this is no longer an unhappy thing, it's a happy thing when you can dominate it. As always, do good work and be safe.